We are going to try out this recording thing and hopefully it works okay. So today you guys are going to be learning about number problems, which in your textbook, sorry, let me step a little quick, is going to be on page 440. So hopefully you guys have it pulled up to that. Yeah, page 440, number problems. So let's look at our objectives. So the last section, which you guys had before your quiz, was learning how to solve fractional equations. And remember that was the type of equation where they had a variable in the denominator. Today our goal is going to be using these fractional equations to solve number problems. So let's go ahead and look at this first example one. So they give us this word problem that tells us that the numerator of a fraction is 15 less than the denominator, and the fraction is equal to 4/7. So we have to figure out what that fraction is. So if we set x equal to the denominator, we know that the numerator is 15 less, so x minus 15 must be our numerator. And we know that that whole thing is equal to 4/7, so we can just set that up as an equation where we have x minus 15 up in the numerator, x in the denominator, and set it all equal to 4/7. So we're going to solve this similar to how we learned in 9-3. We're just going to multiply both sides by the least common denominator. In this case, we have x in one denominator and 7 in the other, so our LCD must be 7x. So if we multiply both sides by 7x, it looks like this. I'll give you guys a second to copy that down. I'm sure I'm going way too fast. So then we can go ahead and cross cancel our denominators. On the left hand side, the x's cancel out and we're just left with a 7. On the right hand side, the 7's cancel out and we're just left with an x. So we're going to get on the left 7 times the quantity x minus 15, and then on the right equals 4 times x. And now we can just solve this like any normal equation. We'll distribute that 7. So we'll get 7x minus, let's see, what would that be? Minus 105, I think, equals 4x. Let's see, 7 times 15. Yeah. So 7x minus 105 equals 4x. And then we can move the 4x over to the left-hand side, we get 3x. Move the minus 105 to the right, we get positive 5x. 105 divided by 3 is 35. So we get that x equals 35, and then that tells us that the numerator, x minus 15, is 20. So if we were to set that up as a fraction, we would get 20 over 35. Okay, so now I have a theorem for you guys, which is also in your books. It says that for all positive real numbers, a and b, if a is less than b, then 1 over a is greater than 1 over b. So if we think about that with real numbers, we have 2 is less than 3. We could say that 1/2 is greater than 1/3. So it's kind of looks complicated when you just see it like this, but if you think about it with a real number example, it's a lot easier to picture. So we're going to be using this theorem going ahead with the next few examples, so I'll give you guys just another second to copy this down. It's hard to guess what pacing is doing this on a video, but hopefully I'm doing okay. Okay, so let's go ahead and try this theorem out with another example. So the problem says that If the difference of reciprocals of two positive numbers is 1/6 and one of the numbers is 3 times the other, then find the numbers. So we know that they're both positives, so let's let L equal the lesser one. Then the greater one is 3 times L. And we are talking about the difference of the reciprocals. So I'm going to set this up as the reciprocal of each. So we have 1 over L and 1 over 3L. Then we know that the difference is 1/6. So we have to figure out which order these are going to go in, right? If they're both going to be positive. So we can use that theorem. So we know that L is a positive number, or in other words, L is greater than 0. And that means that 3L must be greater than L. So then by our theorem, 1 over 3L is less than 1 over L. If that makes sense. So for example, like if L was, say, 3, then that equation would tell us that 1/9 is less than 1/3. So that makes kind of sense if you think about it that way. So since these are both positive numbers, we want to write them in the correct order. So we're going to take the greater number minus the lesser number to get the difference. So we'll have 1 over L minus 1 over 3L equals 1 over 6. And then I bet you guys can guess that we're going to do our favorite thing here and just multiply again by the least common denominator. So if we have L, 3L, and 6, then our least common denominator is going to be 6L. So if we multiply both sides by 6L, we can cross cancel our denominators. And it's going to give us that 6 minus 2 equals L. 6 minus 2, that's just 4. So we get that L equals 4 and 3L equals 12. So those are our two numbers, 4 and 12. So I'll give you guys just a moment again to get caught up here before we move on to the next example. And if I am going too fast on these, somebody can probably get up just on the smartboard and click the pause button. That might work too. Alright, let's try one more of those together and then I'll have you guys do one on your own at the end. So this problem tells us that the difference of reciprocals of two numbers is 1/6 and one of the numbers is 3 times the other. Find the numbers. So I want you guys to just take a second and look at this problem and think about what's different between this one compared to the one we just did. So hopefully maybe one of you guys noticed, it just says that it's the reciprocals of two numbers. It doesn't specify that they have to be positive. So that means that we have to solve this a little bit differently than what we did before. So let's go ahead and just set x equal to one of the numbers, or you can use whatever variable you like. Then 3x would equal the other number. But the difference here is that we don't know which order to put these in. So we know that our reciprocals, again, are going to be just 1 over x and 1 over 3x. And we're going to have two scenarios. So if 1 over 3x is less than 1 over x, then we're going to write that 1 over x minus 1 over 3x equals 1/6. And that follows kind of a play off our theorem there by putting the greater reciprocal before the lesser one. But we also have the possibility that 1 over 3x might be greater than 1 over x, in which case we're going to have to write those in the opposite order because 1 over 3x will be the greater minus 1 over x, which is the lesser. So hopefully that makes sense how we can have to look at both those cases. And then I'm actually going to use a little trick here to make these look more similar. I'm going to take that bottom one and multiply every part of it by -1. And then all of our signs would change. So we would get that 1 over x minus 1 over 3x. We use the commutative property there, equals -1/6. And that's going to help set us up for our next step because now our left-hand sides look the same. So now we have that either 1 over x minus 1 over 3x equals 1/6, or that exact same thing equals -1/6. So if something either equals the positive of a number or the negative of a number, we can say that the absolute value of that whole thing equals 1/6, right? So we can solve this for the positive case, and that would give us that x equals 4 and 3x equals 12, which is what we got on example 2. Or, in the chance that it all equals -1/6, we would get that x equals -4 and 3x equals -12. So we actually have two different sets of solutions. It can either be 4 and 12 or -4 and -12 for our numbers are going to give us solutions when we don't know that they're both necessarily positive. So if we simplify that, we end up with 12 equals 3k. Divide both sides by 3, that gives us k equals 4. And for our other number, we have 4 times k, which is 4 times 4, so we get 16. Therefore, our two numbers are 4 and 16. So hopefully you guys got that. If not, feel free to rewind and go through if you have any questions. Otherwise, I'm going to go ahead and move on to our next example. So this one says that the difference of the reciprocals of two numbers is 3 over 16, and one of the numbers is 4 times the other. Find the numbers. So again, the only difference here is that we're still using the same numbers, but they aren't necessarily positive. So this is going to be a lot like example 3. So go ahead and somebody please click the pause button, and then when you guys are ready to check your work, go ahead and click play. Alright, so I used n for my variable this time, and I said if n is one of the numbers, then 4n must be the other number. So then I can set up my reciprocals, and I have 1 over n and 1 over 4n. So now I have to think about my two cases depending on which one is greater. So if 1 over 4n is less than 1 over n, then I'm going to have that 1 over n minus 1 over 4n, my greater minus my lesser, is equal to 3 over 16. And similarly, I'm going to have the opposite, where 1 over 4n is the greater reciprocal. So I'll have that first minus 1 over n equals 3 over 16. And hopefully you guys remembered our trick here. I'm going to multiply that bottom part, both sides, by -1, so that I get the same thing on the left-hand side as I did for my first equation. So now I have that 1 over n minus 1 over 4n equals -3 over 16. So I'm going to take those two equations. Let's see here. There we go. So I've got my two possible scenarios. So I can again say that the absolute value of that left-hand side equals 3 over 16, because we know that it's either going to equal positive 3/16 or negative 3/16. So the absolute value, it's the same. So if it's a positive, we already found out that scenario where we've got x equals 4 and 4x equals 16. And if we solve that where it's set equal to negative 3/16, we're going to get negative 4x and negative 16 for our numbers. So again, we have two sets of solutions where it's either all positives or all negatives. So those are going to be the types of problems that you guys are solving today for your assignment. You're going to be doing page 442 to 443, numbers 2 through 20 even. So that was 442 to 443, 2 through 20 even. I should have made a slide for this. I'm sorry, I'll do that on my next one. And that will be due to Mrs. Lucier on Friday. If you guys have any questions, feel free to go over and ask her. But yeah, hopefully this worked out for our first one. We'll see how it goes.